Hi everybody, I'm Jeff and this is Garage Maker Guy. This is the first video, so it's going to be a little rough, but if any of you looked at the behind the scenes thing and watched me testing the camera and the microphone and all that good stuff, I did mention that one of the first things I was going to do was try to put everything together and build a 3D printer enclosure. So months and months of looking around at all the different enclosures everybody out there has built and all the people that added features to it and all the other things, and they were all over the place. So this is my attempt at trying to save people that are new to 3D printing like myself a lot of time by putting it all together in what I feel are the best features to have in an enclosure. Obviously heat, so we can print ABS and nylon successfully. Also a camera, a bed cam, so we can monitor our prints. Unfortunately, I've had a couple of failed ones, and I'm sure they're not the last. And it's nice to be able to stop a 19-hour print that fails an hour into it, so you don't spit plastic spaghetti everywhere. So what I did is I put together a document with all of the steps and the instructions on how to design it. This one I'm building for my printer, which is a Prusa Mark III. But you can change it to fit any printer, really. Just change the dimensions, and the one thing is to make sure you measure everything before you start cutting up the wood and buying a bunch of stuff. It's a good thing I revisited that step. Otherwise my enclosure wouldn't have been deep enough to handle the bed camera, because I have a support arm that sticks out 6 inches, and it wouldn't have fit. So I'm glad that I measured twice, cut once, and so here we are with the pieces. That's the Garage Maker coin, which I'll put up on Thingiverse. These are the IKEA panels. Thanks again to Terry at Panda Props for the enclosure that he built. That was kind of the basis for this one. These are $25 a piece. They've got a great tempered glass panel in it, and you'll need 3 of them. Glass is a great insulator, not just for temperature, but for also sound. So a couple of the reasons why you want an enclosure, obviously for the heat and to control the ambient temperature inside, but also like this garage, as you can see, I do some woodworking, I do metal work in here, I do a bunch of stuff that creates a bunch of dust, and dust isn't good for electronics, but especially your printer, your filament, things like that. You don't want them getting dirty. It's bad for the fans, bad for the filament, just kind of bad in general. So as you can see, my pool table is doubling as my wood shop right now, but we essentially have the 3 panels, a top and a bottom. Now I went out and I bought some 2x4, 2 foot by 4 foot by 3/4 inch thick maple plywood. They were already pre-cut into that smaller piece, so they'd actually fit in my car. But you don't need to use that. It's kind of expensive. It was like $26 for each piece. And if you use regular 3/4 inch plywood, it'll be substantially less expensive. The side extensions I actually built out of leftover hardwood flooring that I had laying around. So I just glued 2 pieces together and then trimmed it down to the 3 3/4 inch wide by 25 1/8 long. Needed 2 of those. And then we have the back panel, which will just screw on to the back. And then these 2 little 3/4 inch, they're called 1x1s, they're 3/4 by 3/4. And those will sit inside and give something for the back panel to screw into. So you can remove it if you need to get to things, wiring and such. But we've got all the pieces cut and we're ready to kind of mock it up before we glue anything. And I do recommend using glue and screws, because as we all know, these printers move around a lot and there's a lot of vibration. So the better you can assemble this the more likely it will last a long time and you'll be really happy with it. Also, I plan on adding a top section for filament, and I might actually put a hollow base underneath it because I'm going to want to relocate the electronics from the printer. Although the enclosure will help heat that area so we can get better nylon and ABS and other exotic filaments, I guess that's what you want to call them. But we don't want to heat up the electronics if we want it to last a long time. Granted, we're only going to be heating that ambient temperature up to, I think, around 90 to 100 degrees Fahrenheit. So I'll check that again. I might be wrong on that. Either way, if you can avoid heating up the electronics on a regular basis, it's probably good. For the first round though, we're just going to build the basic enclosure, and then we'll add the lighting, we'll add the temperature control, the heater, the Raspberry Pi with the bed cam, and at that point I think we're pretty good and we'll have a nice enclosure. So let's get to it. Now we're getting ready to just put this thing together. We'll have to do this twice. So the first time we're putting it together is just to make sure all the pieces fit, to get all the pilot holes drilled. So when we actually get to the point where we've glued everything down, and after we've stained, we're going to stain all of this. It's in an ebony stain. I think it's a Minwax something. Anyway, so it'll kind of match the black finish on the IKEA doors, and that way when we go to glue it all in, we won't have any problems putting it together. So the main thing we're going to try to do here is to assemble this and get it so it'll go together quickly when we've got a bunch of glue involved. So what I'm doing here is I'm just going to clamp one of these pieces over here and use it as a stop, so the front of the sides is flush with the bottom piece. So this is the bottom piece that we're doing. So you can see here, I'm a big Craig tool fan. So these are pocket screw holes. These will provide a little extra strength. I tend to over-engineer things. Alright, now we'll go ahead and countersink these. There were two additional pieces that had to be cut, and these are the hinge mounting plates. So this is the front. So these actually go on the inside here because those hinges are enormous, and the screw pattern to mount them would require putting a screw here, which obviously that's glass, that's not going to work out very well. Now I've already drilled this side, but what I did after I countersunk those holes, I put the board up and I drilled the holes, the pilot holes through the plywood. It's really important to do, otherwise you'll split that wood. And again, much unhappiness. So, we've already done this one. So now we're just going to put this, the last stop in for the back panel. Again, we're using just a piece of 3/4 inch thick stuff so I can get this thing in the right position before I screw it in. And that looks close enough. So. All right, so we've got the back panel on and we're about ready to put the hinge mounting plates in. So this is just a piece of 7/16 or 1/2 inch thick plywood. These are those Utrusta crazy hinges. They're very cool, but they're a little tricky to get installed when you're not using them as they were intended to on the pre-drilled IKEA frames and stuff. So what I did is I just took both pieces of wood, clamped them together, drilled the holes, and they're marked here where they are. So I have a mirror image of them. So I've got one for that side and one for that side. And then I've got additional holes to mount the plates to the enclosure, and then we'll put the hinge on. The tricky part's going to be to make sure that this hinge, and then this is the part that attaches to the last glass panel, which will be our front door. So when this snaps in like that, that it actually closes all the way around. So I'm gonna just kind of guess that, you know, we basically want it with the piece that goes on the door attached to the hinge, and we want that piece to be flush with the edge of after we bolt it in. So when we bolt it in, we don't want this surface sticking out past this surface. We actually want it exactly the same, so when the door shuts, it shuts evenly. This will probably be a little bit of trial and error, but we'll give it a shot. And be really careful. These things, although they soft close really nice, without the door they have a lot of pressure. And I almost hit myself in the face with this first time I opened it up. And there's actually a little picture of a guy hitting himself in the face and a big, like, no, don't do that. So heed that warning. Okay, we're gonna put the other side on. And then we'll come back and do the door adjustment in a little bit. Hi everybody. Jeff with Garage Maker Guy here. I got it all assembled. The hinges, they are very cool, but you really need to take your time getting them installed and getting them lined up. Took a few iterations to get it right, but that's it. One of the things about the hinges, the glass door is actually pretty heavy, so I had to set the strength. It's real simple. It's a Phillips screwdriver. Had to adjust it on the hinge. The directions that come with this, I don't know if you can see that or not, but they've got a great section on the screw. You just tighten it to make it harder to but more strength or whatever. And then there's some other adjustments inside here, which you still need to get the door pretty much perfect, because the amount of adjustment you have is maybe 1/8 of an inch, if that, either way. So yeah, I probably, I don't know, 2 or 3 times had to get the plates moved right, so the hinges, the front of the hinges with the mounting plates on the door were flush with the front. But today what we're going to do is basically take it apart and stain it. I'll try to do a quick view here with so you guys can see the inside. Let's take a look. Let's see if we can get in here and show you guys what's going on with the hinge. So yeah, let's take a look here. So this is the adjustment right here to make it stronger or weaker. So I got mine about right in the middle. So you just put the screwdriver in there, turn it, and like I said, the instructions go over all that. The other part for the door adjustment is right here. This is up and down. I believe this one is left and right, but you don't have much room to play with. So anyway, we're gonna just take this all apart. Now we're gonna label it, label the pieces in their orientation so the screw holes line up, get it stained, and put it all back together again. I forgot one really important thing that you guys need to be aware of if you use this setup. Because of the hinge plates and where the brackets that connect to the hinge connect to the door are very close to the edge, and the screws that you have to put in, I was really concerned about hitting the glass because I don't know how far in the glass goes, but I'm going to take the door off and try to get a close-up of the hinges so you guys can see just how close I'm talking about. It gets, I was expecting to shatter the glass, but I figured if somebody else had already done this and they didn't shatter the glass, maybe I had a chance. So you basically, you just have to pop this down. Let's see here. And then lift it up a little bit and do the same on the other side. And then it just lifts up and pulls out. So you can see it's just about flush. I mean, it might be in 1/16 of it or 1/8 of an inch. And there's 4 screws. So what I did while I was trying this out to get the position right and lined up, I used a 1/16 inch drill bit. I used the template that they give you with the hinges, but I had to bend off all the tabs because they're designed to put the hinge over here, and that wasn't going to work for us. So I had to flatten it out because I wanted the spacing of the holes. So I did that, and I marked them, and I drilled the all 4 holes, and then I only put the top and the bottom screw in while I was test fitting. So if I had to re-drill the holes and they were close, I would still have 2 really good anchor points. Either way, it came out really well. Just be really careful putting these hinges, the hinge mounting brackets on the glass door, and take your time. I would recommend either using a electric screwdriver with a clutch and set it really light so it doesn't over torque the screw bits, or just do it by hand.